So let's clean up the last thing I wanted to do last time. For the reports. Hope, can you all see this from everywhere? Decently, at least? Okay. I wonder if I can do... Hey, all right, that works. Okay, for some reason WebStorm, I can't zoom in on the screen, on the editor. IntelliJ lets me do that, but I don't know, I've tried updating everything. It's the same platforms, the same ID by the same developers. I don't know why I don't have that feature in this. But anyway, regardless, let's clean up this one thing I wanted to do last time. Is for the project, for each open source library or framework or whatever that you use, you have to fill out a report. So I want to talk about how you would find the code for that. Part of that is a link to the code specifically in that library that does what you need it to do. So I want to give an example of how to do that, how to find that, and get that code. Now, of course, the link that you would send would be on GitHub, but I'm going to go into my editor to at least find that code. Then you would be able to go to GitHub after that, find the link, and then put that URL in your report. So I chose one of these technologies, the how to decode URLs with this library that I have. This is an Express app, and I'm using Express's body parser to be able to decode URL in the body of the request. So I have a form set up. That form is using URL encoding, and then this library is decoding that URL for me, much like we did in homework 3 with query strings, to be able to decode that stuff. So let's figure out how this thing works. And to do that, I'm going to make heavy use of Command or Control on Windows and click. I'm going to hold Command, click on this thing, and it's going to take me right to that source code of where this happens. And this is going to be a lot of chasing through source code, especially for Node. Kind of why I picked Node for this example. Node is a friggin' mess when it comes to this stuff. And let me get out of presentation mode and show you for a second. For Node, to be able to import your dependencies, we have I almost said requirements.txt. We have, oh my goodness, package.json. I was blanking on that. I almost said requirements.txt. Requirements.txt, if you have a Python project and you want to install your dependencies. JSON, we have this package.json file, and this is going to have all my dependencies. I have a decent number for this one. I'm not using them all in this project, but these are the ones that I would use if I fully built this out, used all these features. So a decent number of libraries that I'm pulling in for this app. And then when you run npm install, it's going to install all those dependencies, but all those dependencies themselves have other dependencies. So when I install these, 15, 20 maybe dependencies, it's going to create a directory named node modules. It's downloading all of these dependencies. For some reason, this is part of the ecosystem of Node.js and NPM in specific, is it really encourages very small modules and small dependencies, and then having lots and lots of them. So a lot of these do almost nothing, very little dependencies. Some of these dependencies are just like 20 lines of code even. But this is the environment that NPM encourages. This is kind of the Node.js ecosystem. So let's look through here and figure out where our query strings are actually being processed. So let's go back to our code. I'll go back into presentation mode. This body parser, URL encoded, extended false. So let's go to the URL encoded method. That's going to get a parser with the key URL encoded. Get parser just calls load parser. Load parser gets this parser, checks the name, and if it's URL encoded, we're going to require lib types URL encoded. You can tell I've done this before. You would usually have to look through this a bit. And I'll probably forget at least one step and you'll see me do that. But lib types URL encoded. So now I'm going to exit this, get back to my project structure. I'm in this body parser package, and I found an extra requirement, lib types URL encoded. That's within the same library, types URL encoded, and I want to go in here and figure out what's going on in this package. Now, if I look through here, which I did, there's no URL parsing going on in this entire file. There's nothing, no URL parsing. So this isn't where the action is happening. But if I look through here, I see this require query string, which means this. Oh, there's actually two different ones. That's interesting. Query string, query string. So if I look through here, when it's actually getting the parser, we're getting something called either QS or query string, depending on the settings. It looks like it supports two different actual parsers. So now there's no, like if this were /, oh, I can't edit this. If this were / query string, I would know I'm looking within this module for a file named query string. There's no /, it's just query string. That means I'm looking for a completely separate module. So at this point, I got to go into my sidebar here, go into my queues, and look for some dependency that this dependency installed. Yeah, I wonder what query string is then. Maybe that's an old version of this library. But if I go into QS, I can start looking at the code inside this dependency. Start looking at I was going to try to find the definitive answer on that one. Required by body parser. That's interesting. So I'll try to find the definitive answer on that. But anyway, we're going to go into the code and try to figure out where this library is actually parsing my query strings. Probably in this parse.js would be my guess. And here's where we can finally start finding that code. Now we can finally start seeing the query string code that we would expect. Is this even it? Let's get out of here for a second. I don't even know if that is. Code we want quite yet. I'm looking for where it finds the, well, I guess, you know what, maybe that does make sense. We would assume that the question mark was already found, the query string was already extracted at this point. I'll buy that we can expect the query string to not be in here. In fact, let's go on a little adventure here. I'll buy that. It's because this is the body of a request. We wouldn't have any question mark. I'm looking for something that shouldn't even exist in there. So let's go back to our other library. And we can see we're looking for this delimiter, the ampersand. That's going to separate our values. So we're splitting on that delimiter to get all the separate individual key value pairs. And then we're looking for these equal signs. Either an equal sign, or we could have this bracket notation to be able to define a set. You can have, or not a set, but an array. You can have an array as a query parameter that we didn't talk about, but it's something we can have, so the library better support it. Looking for empty arrays and parsing Oh, that's not the delimiter I wanted. And looking for all those equal signs to be able to split. After it's split on the ampersand delimiter, looking for all those equal signs to split the key and value, and also looking for that array notation in case there are arrays in the query string. So this would be the file where we would, where you would link your code. So actually, let me just finish this up. Site go.com. And then we'd go to GitHub, find that file, and this would be the link that you'd put in your documentation. I'm using body parser to parse query strings. Here's the link to the actual code that's actually parsing my query strings. And that's what I would expect in that report. So it's, by definition, you're using open source code. By definition, you can find the code. It's open source. The source is out there. So I want to see where is that exact source that's doing the specific thing that you're using that to do. Same thing if you're doing, you're using a framework, web framework for routing. Show me that code that's actually doing the routing. That's saying if the pattern matches this path that you gave me, run this function. Show me that code that's actually deciding where your requests are being routed. Yeah.
What if you're using like a Java library that you weren't allowed to use before?
That you weren't using before? What was it?
Yeah, like if you use like a Java library that parses for you, that you weren't allowed to use before, how would I list that? There is no source code.
Yeah, the same way. There should be source code for that. What do you have a library in mind? I can try to run through one from scratch. I did want to do that just to show you that I didn't completely pre-prepare that thing. Is it part of Java itself?
It's like an external, but
So
I think it's part of Java. I'll go back.
There should be some
I think it's servlet.
servlet.
Yeah.
Okay.
I think it comes with the EE Enterprise Edition.
Ooh, that might be an issue, won't it? But we'll handle those cases as they come. If it's freely available, but not open source, yeah, we'll cross those bridges as they come. Yeah, and EE, you'll have a lot of work to do in the licensing side. I believe EE has some licensing issues. I forget what they are off the top of my head, but we'll have some licensing.
You're figured download though. Like you can download the close version of Java.
But there are licensing things. You'll have to look into them and figure all those out if that's what you're using. I believe they will want you to pay for their license to be able to use that out in production. Like you can develop, a lot of software is free for development purposes. You can get your student accounts and get all kinds of crazy stuff for free. But once you start going out to production and making money off of it, they want their cut. All right, any questions on this or anybody? I kind of did want to go through one on the fly, if I'm brave enough for that. Anybody want to try it? Because at the same time, I kind of didn't want to do that because so many things can go wrong. I can do it, just probably not in 5 to 10 minutes. But that will take a while. Don't take that for granted. When you're just pulling in a library and saying, I'm going to use this because it makes my life easier, just keep in mind, I am expecting you to know what that thing is doing, how it's doing it, and where that code is that it's doing it. Not in any great detail. Like that file I showed you, I don't expect you to say, okay, line 17 does this, line 18 does this. I don't expect you to describe what that does. I just want you to say, it would suffice to say, I'm pulling in this library to parse my query strings because I don't feel like it. Here's the code that actually parses my query strings, the part that I'm concerned with. And the rest of that code we looked through was just overhead routing, the 413 responses saying that the path was too long, things like that. We don't have to be too concerned about that. That's functionality you're not pulling the library in to do. Yay, it's nice that it has extra features that you don't have to code, but that's not why you were pulling that library. You're pulling it in to parse query strings in this case, or the body of a post request when it's URL encoded in that specific case that we just saw. Any questions about that in general? Just want to make sure it's clear what is being, what's being asked for you to do there. Okay, whoa, wrong slides. Docker and deployment. So let's talk about Docker. This is one of the big new requirements for your project, is deploying with Docker. So let's start with a little vocab. I'll be using these words throughout the semester. I've used these a little bit before in the semester. I think I slipped and just started using these, but I want to use these throughout. So let's start introducing just a little bit of vocab here. Development environment and production environment. So development environment, usually shortened just dev, is where you're writing your code. This is typically your laptop or your desktop. This is wherever you're developing your app, testing your app, and adding features. All of that good stuff that happens. You're finding and eliminating bugs. This is where all your apps have lived so far. This is where your homeworks have lived so far, is this development environment. But now we want to start talking about the difference between these two environments, because we're introducing production environment, or prod, usually for short. If you see dev and prod, this is what that developer is talking about. Production environment is where your app is actually deployed. This is where users are going to interact with your app. Can be a server on a rack somewhere. This is wherever your app lives when it's actually live to the world. This is the production environment, we call it. And needless to say, we don't want to see bugs in production. Bugs in production, they happen all the time, but they're scary, they're frustrating, they're painful. So one of our main goals is developers, the reason we test things, the reason we always talk about testing and things like that, is we don't want to see bugs in production. An end user seeing a bug is a horrible thing. You've seen bugs as end users, I'm sure. It's not a pleasant experience for the user. It's definitely frustrating for the developer. It's a tough thing. So that's one of the big things we want to avoid, just in general as software engineers. Bugs in production, very bad thing. It happens, but anything we can do to avoid them is something we're going to do. So there's a lot of headaches that come with this. A phrase you've probably said in classes before: it works on my laptop, but then you submit to Autolab and it doesn't. Autolab is effectively your production environment when you're submitting auto-graded coding assignments. That's your production environment. Your laptop's your dev environment. It works on my laptop. I deploy to production, and it just doesn't work. This is a common thing. Of course, what we're talking about today usually isn't the case specifically for Autolab. Usually it's something else that's wrong. What does it mean to work on your laptop? But let's not go down that road. So everything works on your laptop. You test it. Everything's fine. Deploy to production, and let's say the app just doesn't even run. There's a lot of things that can cause this. We can have different versions of all the dependencies, all the extra software we need. We can have hard-coded paths. This is something we saw a bit on homework 3. We're lenient with that in the grading, but that's something that would completely break your app. If you're deploying with hard-coded paths, if you have C:/ and I'm trying to run that on my Mac, there's 0% chance that my Mac's finding that file. If you have that hard-coded absolute path instead of relative paths relative to the working directory of your project, that can really, that'll break everything. That's a clear only works on my laptop issue. It'll cause that. Your environment variables might not be set up the same if you're using environment variables, especially if you're storing database passwords, and environment variables is a common thing. If you have those environment variables set up differently in the two different environments, that's something outside of your app that can be different across those. And all kinds of other things. You can imagine what else would cause issues moving from one machine to the other. Maybe it's just the fact that they're different operating systems might be breaking everything. Maybe the dependencies you use only work on Windows, which is something that happens. You use some DLLs. Well, that Ubuntu environment that you're deploying to isn't going to know what a DLL is. It's not going to be able to open and run that thing. So one solution to this is using virtual machines. A virtual machine is a complete simulation of an entire machine running on your device, on your machine. So some of you have probably used these and seen these before, where you have a Windows machine, but you want to run Ubuntu on your laptop. You would spin up a virtual machine, and you can have your Windows OS and a simulation of an Ubuntu OS running at the same time. You can have two operating systems. You could run both of those at the same time. However, these have some restrictions. If you do run a VM and you run that on your laptop, you know that it's pretty slow. You need to have a lot of hardware, a lot of power behind your laptop to be able to run that, or your desktop, to be able to run those two machines. You're running two complete new environments off of the same set of hardware. All those resources are effectively, cut in half depending on how you allocate your resources to each one. So it's very inefficient to be able to do this. If you've done this before, you've seen that, you know that things slow down quite a bit. But it does get rid of our problem. There's no surprises in the deployment environment. If you fire up a VM, a complete simulation of an environment, test your app in that VM, and then run that same exact VM in production, you solve that issue of it only works on my laptop, it only works in dev but not prod. You get rid of that issue because you're using the same exact environment, and that's what we want to talk about today. So VMs are kind of the answer. They were the answer for a while, but now we have something new and shiny, but it's not so new anymore, in containers. So containers are the cool new thing to use instead of VMs. It solves the same problem, but containers are effectively very lightweight VMs. We can run lots of containers on the same machine and not experience those same slowdowns. So we want to solve the same problems that VMs were solving, but now we have a newer technology, containers, which are just going to be more effective, more efficient to be able to solve the same problem. Now we get all those advantages, especially cross-platform. You run a container or a VM, the same thing, on a Mac, on Windows, on Ubuntu, on whatever can run, in our case it's going to be Docker. Whatever can run Docker is going to have the same exact environment because it's running inside that container. So these are very portable too. If I have a Docker container, if I have a container spun up on my laptop, I can take that container and move it over to some other machine, have that same exact environment running somewhere else. So this is what we want, this is what we want to do, and just really completely eliminate the difference between dev and prod. We want those to be the exact same environment, just running on different hardware at different times. And also across members of your team. If you want, I've seen a lot before where an app runs well on one team member's laptop, but not on anyone else's laptop. Well, Docker is going to solve those issues too. If it runs on one person's laptop, it's going to run on everybody's if you're deploying with the Docker container, if you're testing with the container itself. So there are a lot of quality of life improvements between dev and prod specifically, but there's also some security things we can do. This is kind of a separate thing. I guess not too separate. But another thing that we get from containers is that the container is running in an isolated environment. Ideally, I'm sure there's some fancy attack that's been found that Docker's constantly patching new vulnerabilities. I'm sure there's some case like that. But you're not supposed to be able to break out of that container. As far as I'm concerned, you can't break out of those Docker containers. So if you're running code inside a Docker container, you can't access the host machine. So if I have some very dangerous code I want to run, I could run it inside a Docker container on my laptop and not worry about my laptop being destroyed. So from inside of a Docker container, nobody's going to do this scary command in Ubuntu or any Unix-like operating system and just destroy the entire system. They can't do that. They're only going to destroy the container that code is running inside of. So this is a nice thing to have if you're running your app in a container and somebody does find and exploit a code injection attack. Somebody's running code on your server, they uploaded it through your site, found some vulnerability, got code executing on your server. They're not destroying your physical server box. They're not actually destroying your hardware. They're just destroying that container. And then your DevOps team, they see that the container was destroyed. They spin up another container that's an exact copy of that other one. Hopefully, after you patch patch it. You get that patch out, plug up that vulnerability, get that new container up, and everything just keeps going along. You have some downtime there, yes, but you didn't destroy hardware. You don't have to reset up an entire box. You just run your Docker commands again, get another Docker container that's an exact copy of it up and running again, and you're moving along. It's still a horrible thing because you have a code injection attack, a code injection vulnerability that has been exploited. Still a big concern, but not as big of a concern as it could be if you're running without Docker. There are also apps where you have to have code injection attacks. You have to be open to code injection. Autolab, in my world at least, is one of the big ones. We have to take student code and run it. By definition, that's a code injection attack. That's a feature of the app, is that it allows code injection attacks. We take your code and we run it. So how do we do that without allowing a student to just destroy everything, or allowing a student to navigate the system? What if somebody uploaded an Autolab assignment, completely ignored the assignment itself, and wrote some code that accesses the database with everybody else's grades in it and returns that to them, or just prints it in the Autolab output? That's a big concern. We have to protect against that. We can't have that kind of vulnerability. So what we do is every time you submit an assignment, we run that assignment inside its very own Docker container, do the grading inside that container. Now, even if somebody runs rm -rf / even if somebody does that and destroys that entire machine, all they did was destroy the container that was built for their specific submission. If you ever wondered why Autolab takes, there's about 12 seconds of overhead when you submit, even if it's just a hello world, even if it's creating almost nothing. There's about 12 seconds of overhead. That's creating the Docker container for your submission and then destroying that Docker container afterwards. So you get a brand new, fresh container, a very fresh instance of Ubuntu every single time you make a submission in Autolab. So that's that overhead if you ever wondered. But we have to have code injection attacks, so we have to have some way to protect against that. So Autolab itself is running in a Docker container, and then Autolab creates more Docker containers for each submission. So we have a few layers of protection. To be able to submit an assignment that actually destroys our physical box is, I'll say next to, I'll hedge my bets just a tiny bit there, but next to impossible. You're not going to be able to destroy our hardware, destroy our host operating system in that. Out in the world, AWS, Heroku, DigitalOcean, just a few examples, but any hosting service, anywhere where you can deploy, give somebody some money and deploy your app on their server, by definition, they have to allow code injection attacks. You're sending them your code and they're running your code on their servers. They have to run something. They have to either have VMs or containers, or else you could deploy to AWS and break Amazon. They're not going to allow that. They're not going to let that happen. They have to protect against this. And as far as I know, I believe all these are using containers at this point. Actually, I'm not familiar with the internals of each of these. So they're either using containers or VMs, though. They have to have one of these two solutions. Your code has to be isolated from their local environments. So Docker is the specific solution we use. I'm not even aware of a competitor to Docker. This has pretty much become standard across the industry. If you're using containers, you're using Docker. They're pretty much synonymous at this point. So Docker, this is the software you use to create these containers and run our code in isolation, which means this is software that you have to install on your machine, install it on your laptop, install it on your desktop, install it in production if you do have a server. If you have a DigitalOcean account and you have a server over there, install Docker there. Docker is going to be that entry point into this world of containerization. So to work, I feel like I've been talking for a while. Any questions at this point? Okay. So most of that was background. What are we trying to accomplish? Now let's see specifically, how are we actually going to do that? So to do that, we're going to write what's called a Docker file, which is a file just literally called Docker file with no extension. And Docker file is going to be used to create Docker images, which are going to be used to create Docker containers. So let's create an image first. And a Docker file is going to be similar to a Makefile. It's not really the same thing, but it has a lot of similarities in that it's a set of instructions that's going to tell Docker how to create the image. Just like Makefile is a set of instructions telling your OS how to create an executable. Similar things, similar ideas. Of course, the similarities break apart pretty quick. But you can think of that if you're used to Makefiles or CMake. I believe when you took 250, that's what we were using at that time. It doesn't sound right, does it? Anyway, but whatever it was, whatever you're using to compile your C++ programs, either Makefiles or, I think it was CMake at the time. Is that a thing? Does that sound familiar? Oh well, we'll move on. 250 was in the past, right? All right, so here's the Docker file. This is the Docker file for that Node.js app that we were in, which, by the way, that app doesn't really do anything. I just built it for examples. But I just needed a small enough app that it was easy to navigate around. So here's the Docker file for the Node.js app. Let's go through this thing line by line and see what's in this thing and what the commands are. And I'll show you how to write a Docker file by example. So we start with this from line. The first line of your Docker file is going to specify the base image that we're going to use, that we're going to start with to be able to start making this Docker image. So for this, I'm going to start with Ubuntu 18.04. I'm going to get my entire copy of Ubuntu 18.04 as my starting point. So since this is going to be an Ubuntu image, everything throughout the file here is going to be able to use Ubuntu commands. So I can run commands. Any command that's going to work in Ubuntu is going to work in this Docker container, or Docker image, which will be used to create Docker containers. There are a lot of other images. A few that we'll see later on in the semester, there are images for the databases we'll use. We can have a Mongo image, spin that up, and then run our app image and have it connect to our MongoDB image. We'll do things like that with multiple Docker images. For now, if you just start with Ubuntu and run Ubuntu commands, as long as one member of your team is familiar with Ubuntu, they should be able to get this Docker file up and running. So Ubuntu, or if you find a specific one, you want to explore the other images that are out there. The documentation that I linked actually uses a Node.js image as its base image. Node.js Slim, I think it is. It's a very lightweight Linux-like environment, but just for Node.js apps. So there are other images out there if you want to explore. I'm just going to use Ubuntu because I know Ubuntu is going to work with any app that any of you are going to build. Next, we're going to see our first run command. Run, if I use that run keyword, it's going to run that command in the base image. So this is where I can start running Ubuntu command line commands. So if I have a brand new image of Ubuntu, a brand new Ubuntu 18.04 operating system, what are some of the things I need to do to get this set up? Some of the things where even if you're running Ubuntu, you probably forgot that you ever had to do these. Or with this line in particular, a lot of tutorials just say run this line first. It's something you need to do to update all the repositories where you can pull from apt-get. So if I don't run this, I might not be able to find some of my apt-get stuff that I use later. These things just might not exist if I don't update. So the very first thing I'm going to do is update apt-get to make sure I have all the latest repositories. So I make sure everything's available. This is something you do kind of naturally. You might not think about it even if you run Ubuntu, but we got to do it. We have a very fresh image of Ubuntu. Let's update our apt-get, the very first thing.
Wouldn't you also need to add the runtime environment for whatever language you're using?
Yeah, that's going to be your.
Oh,
We're getting
I'm just having a note.
Yeah, since this is a Node app, I only have to add Node.js. Yeah.
Is this all once Docker is installed, or is this installing?
This is after Docker is installed. Yeah. So we're gonna tell Docker to build an image off of this off of this Docker file. This is after Docker's installed. Installing Docker, I won't cover that because it's different for every operating system. But go to the Docker link that I gave, or just search Docker. It'll give you the install instructions for whatever operating system you have.
We wouldn't want to install it if we don't have the right version of Windows.
Ooh.
So if it wants Pro or Enterprise, I think, it's a very specific version.
Let's talk about that after lecture. I'm not aware of that with Windows. Was that the other questions?
Is this the normal version of Ubuntu file, or is it a specific maple now?
So Docker made a Docker image off of Ubuntu 18.04. So it should be mostly the same, I'll say, but I wouldn't be surprised if there are some slight differences because of making it as a Docker file. For example, I don't know which specific update version it is, or if that's updated in Docker itself. But it is all of Ubuntu 18.04, but there just might be some slightly different configurations.
Would it download Ubuntu 18.04 every time you run this Docker?
No. And that's one of the big advantages that Docker gives us. So the question, is it going to download Ubuntu every time we run this? No. So it's going to download it the first time we create an image of this, and then if we make any changes to this Docker file, Docker only runs the commands that have changed. It has something similar to Git with all its versioning and everything. It'll only look for the changes and run those changes, and it's pretty sophisticated about how it does that. And even the first time you run it, from my experience, it doesn't take that long to get the Ubuntu image, because it's not installing Ubuntu, it's just downloading the image. So it's just however long that takes you to download on your network.
Is Docker and its function, is that similar to like a VMware or a VirtualBox?
Yeah. Yep, it's similar, except those technologies are for virtual machines, and this is for containers. But it is similar, yeah. Yeah.
You don't need stuff like sudo in Docker when you write it out?
No, so in the Docker file, we're running it as root, so we don't need sudo. All right, let's.
I'm assuming if one of those things blows up.
Yeah, if any of these are wrong, it's.
My limited
It doesn't
experience with Ubuntu is you can have install commands that work 1 month, and then the next month, everything's happening.
And that's why I'm kind of hedging my bets on what that first line, what exact version of Ubuntu it is, because I believe that doesn't change, and I think that's why we have to do the update.
Okay.
Because since that's not changing, so the whole idea of the container is stability. We want this to be the same exact environment all the time. So that Ubuntu 18.04, I don't think that does change, so we're not going to have the latest updates. Of course, once we run the update line, yeah, we might get different stuff there, depending on the time frame. All right, let's get through the rest of this, though. So the first thing I'm doing, this is, depending on some of your preference, I suppose, but we want to define which directory we're working in while we're building this image. So I'm saying my home directory is going to be root to make sure that my home directory is set to the directory that I'm working in. So anything that works off of the user's home directory is going to have the right directory set. And then, and I'm doing that through this env, setting an environment variable. I'm setting the home variable to the directory that I want to work in. Then I'm going to change my working directory to root, that same directory, which means, which is the same thing as saying cd/root. I'm going to change into that directory, but in the Docker way, so Docker knows that I'm in that directory. Instead of saying, we wouldn't say run cd/root, Docker, we're going to use workdir, working directory, /root, to let Docker know we're in that directory. That's the directory we want to work in. And that'll be important for this copy command. This copy command is a Docker command, not an Ubuntu command. So if we didn't change working directory here, copy isn't going to get our files in the right spot. So specifying the directory we want to work in. And then all our setup. Some of this order is a little bit arbitrary from what I did. What I'm doing, this could be before the directory setup, that'd be fine. But you do have to be aware of the order if there are any dependencies, which we'll talk about in a second here. But I want to install just Node for this one, Node and NPM, so I can install my dependencies. Anything you need for your language would go here. If you have a completely brand new, fresh Ubuntu install, what do you need to be able to run your language? What compilers do you need? What interpreters do you need? What dependency management software do you need? Anything you need to run your language, run your app, any extra software you'll need. For my cases, it's just Node.js and NPM, and I needed this fix missing to, I forget what exactly that did, but without that, things break. So I had that fix missing in there. Next, I want to copy all of the files. This is a very important line. I want to copy all of the files of my app into the image. So for this, I'm doing copy ... This is the directory in my host machine that I want to copy, and then the directory in the image that I want to copy that to. And this will copy recursively, so it'll look in all your subdirectories and copy everything over. So I'm going to copy all that. I'm running this, I'm going to run this, and you're going to run this. I mean, I guess if you don't want to, you could change that path. But run this from your from the root directory of your project. And when you run from your root directory of your project, that first dot is going to refer to the root directory of your project and refer to everything in your project. And since we set the directory up here to /root, the second dot is going to be /root in the image. So I'm copying all of my app files into /root in the image, and /root is my working directory. So whenever I run commands, it's being ran from /root. So I can assume that in the container, after this copy is called, that I'm running commands from the root directory of my project, and that all my files are there, that all my files are existing in that directory, in my current working directory. Now this is one place where order is critically important. I want to install all the dependencies of my app. So for Node.js, if you're not familiar with it, we have that package.json that we saw earlier that specifies all of my dependencies. In whatever language you're using, you're going to have some dependency management to handle all of your files, or what I'm sure I'll see sometimes, I discourage this, but you might put all your dependencies in your Docker file. I wouldn't do that, but I have nothing saying that you can't. So, but you should use some dependency management for good practice. And then I'm going to run npm install, which is going to go to my package.json, download all the dependencies of my dependencies, create that node modules folder with all of that stuff downloaded, and get all of that good stuff into my app. This order is important. This has to happen after copy, because if I run this before copy, I don't have a package.json file. That file hasn't been copied into my image yet. So this doesn't have anything to install. It wouldn't do anything, or at worst it would crash. It would give me some errors. And then I copy in my files. Now I don't have my dependencies in there, so that could cause some issues. But anything you need to do to get your app set up, after you copy in those files, run all those commands to be able to get your stuff set up. Next, an important line. I guess they're all important. I didn't add anything extra in here. For the sake of example, it's pretty minimal at this point. Is exposing a port. So Docker containers are meant to run in isolation. So if we do want any outside interaction with this container, we're going to have to explicitly say that. So expose 8000 says port 8000 of this container is allowed to be accessed from outside of the container. If I don't expose that port, I'm not going to be able to access my container. Since we're using containers to run web apps, it's a pretty important line. If you're not using it to run web apps, this isn't as critical, I suppose. If you don't have any ports that you want to access, but we're running web apps. For the project, you have to specifically expose 8000, run your app on port 8000 to be able to get this up and running. And then finally, the command to actually run your app. Now, the most important part about this line is that we use cmd, command, and not run. So run is a command that's going to be executed when we run this Docker file. When we tell Docker to build the image, every run is going to be executed, and it's going to go line by line running all those things. Command won't be executed until we actually run the container based on this image. So it's very important that running our app does not use run, we use command for that, and then separate our any space would be, separate our arguments, our program and our arguments in this array style with strings. Now, if we use run there, when we build this Docker file, your app never stops. So your image never is finished building because Docker is going to wait for your app to stop running to be able to say that the image is complete. That's never going to happen unless your app crashes, and then you got other problems. So CMD say, hey, Docker, when you're building this image, don't run this line. But when I run this container based on this image, definitely run this line. So we have a Docker file which can be used to run to create a Docker image. And we can do Docker build -t, whatever you want to name your image, and then dot to specify the current directory. But we wanted containers, not images, and we have an image. What do we do with that? Well, we can use that to create containers, similar to classes and objects would be my analogy. An image is like a class. A class doesn't really do anything. I mean, unless you have static stuff. Let's not go down that road. But a class doesn't really do anything, but you can use that class to create objects of that type. And that's our difference here. We can use one image to create many containers after we have that image. And we run that container with, this is the line, you can run it a lot of different ways. This is the line that we're going to use when running your apps, when testing your apps, so definitely make sure your app works with this line. You can use other ways of running it, different options and stuff to be able to run your app. When you're testing, for example, if you do Docker run and then the image name, it's going to do something very important for you. It's going to display your errors if you have any. So if this isn't working, just try Docker run image name, and you'll get to see any errors if it's crashing of what's going on there. But this, just very quickly, and then we'll start Friday by giving an example. I'll give a live run through of this. But exposing that port, mapping a local port to your 8000 inside your container, running your container in the background, and whatever you named your image to be able to run that. And if everything works, your app's running on local port.